Hello to everyone, and welcome to part 3 of this video series. So the part 1 was 2021, June 2021 differential equation, and the part 2 was June 2020 still differential equation. So this is the part 3 of this video series. So if you haven't checked out part 1 and 2, I'm going to put a link in the description box, and also above here. If you click on that, you're going to see a playlist of all the questions under differential equations. So today we're going to be answering June 2019, and this will be question 1. So question 1 says that find the complementary solution of the differential equation 2d squared y all over dx squared minus dy dx minus 3y equals 5 e to the minus x in the form y equals to f of x. Hence, find the particular integral and the general solution in the form y equals to f of x. Now, looking at our differential equation, so we're going to call this our equation star. Now, to get our characteristic equation, we simply be n squared minus n minus 3 equal to 0. So the roots of this our characteristic equation will determine which complementary solution we are going to use. So therefore, when we look at this, we are looking for the factors of minus 6. So we see here that we have minus 3 and 2. So we are going to have 2n squared plus 2n minus 3n minus 3 equal to 0. So we're going to factor out 2n there, so that we'll be left with n plus 1, and we're going to factor out minus 3, so that we'll be left with n plus 1. So you see n plus 1 is common, so that we're going to have 2n minus 3. So clearly you see here that our n1 should be minus 1, and our n2 should be minus should be 3 on 2 basically. So that's our n2. So clearly we see here that we have two real and distinct roots. So we know that from y complementary equals to a e to the n1x plus b e to the n2x. We're going to have our complementary solution to be a e to the minus x plus b e to the minus plus 3 all over 2x. So basically that's our complementary solution. Now, since when we compare the particular solution here and our complementary solution, we discover that 5 e to the minus x and a e to the minus x. So our particular solution is part of our complementary solution. Therefore, y particular in this case is not going to be a e to the minus x, because our particular solution is part of our complementary solution. Instead, our y particular is going to be ax e to the minus x here. So this implies that our first derivative dy all over dx will simply be equal to a e to the minus x. So in this case, I've differentiated x. Now if I keep ax constant, it will be minus ax e to the minus x. So I'm done with looking for the first derivative. Now moving on to the second derivative, d squared y all over dx squared. This will give us minus a e to the minus x. And now looking at this, if we factor out minus, we see that this is going to be exactly the derivative of this function. So it will be a e to the minus x minus a x e to the minus x. So if you are confused or you're lost at this level, just do your normal derivative and we are going to arrive at the same answer. So looking at this, we're going to have negative 2a e to the minus x plus ax e to the minus x. So we're going to combine all of this in our equation star. So if we call our first derivative to be equation 1 and our second derivative to be equation 2, so we say equation 1 and equation 2 in equation star will simply give us 2 dy dx. So we're going to multiply 2 times all of this, so it will simply be minus 4a e to the minus x. So we're multiplying by 2 plus 2 plus 2a x e to the minus x. So if we look at what is above here, minus dy dx, so minus dy dx will be minus a e to the minus x plus ax e to the minus x. So minus 3y, so minus 3y minus 3, our y is ax e to the minus x. So all of this will be equal to 5 e to the minus x. So we have that above there, 5 e to the minus x. So now if we cancel, we see that e to the x is common all through, so we are going to cancel e to the x, e to the x, and e to the x. So we see that on our right hand side we have a constant 5, so we are going to be comparing our coefficients. So we see that this and this will give us this and that will give us minus 5a, minus 5a. We are done with all the constants. Now all the terms in x, we have 2a x plus ax will give us 3a x. So minus, so this and that will cancel each other, so this will be equal to 5. So a, this implies that our a will be minus 1. Very good. So we have our a to be minus 1. So it means that our particular solution will simply be equals to ax. So it will be minus x e to the minus x. So from here, our y particular will be ax e to the minus x. So now looking at this, to get our general solution will simply be, our particular solution, y general, will simply be y particular plus y complementary. So looking at this, when we substitute our value, we are going to get y general to be equals to, our particular solution is minus x e to the minus x. Now our complementary solution, as we saw, was this is our complementary solution, a e to the minus x. So a e to the minus x plus a e to the minus x plus b e to the 3 on 2x, I believe, e to the 3 on 2x. So this is our general solution. And since conditions were not given to us, then we are going to stop at this level. But just to like elaborate more, most at times they're going to give us conditions like x equal to 0, y equal to 1, when dy dx is equal to, let's say, 8 or any value. So in this case, when conditions are given to you, you simply need to substitute them and get the value of a and b. At the end, you come and substitute the values of a and b. That will be the exact solution, the exact general solution of the differential equation. So that is it for this video. Please, if you found the video helpful, you can give me a like. If you want to see more of this type of videos, you can give me a follow or just subscribe to my channel, share to all those who this information or this video might be helpful to them. See you guys in the next video.